Hello everyone, welcome to Concepts in Chemistry YouTube channel. So this is the third video of memory based question and maximum possible answer series of Barc 2022 first phase uh, chemical science exam. So we already upload two videos and we already discussed around 27 questions in those two videos. So in this video we will discuss more questions. So let's start. So question number 28. So this compound was given and we have to find the IUPAC name. So if you see the stereochemistry of each uh, chiral center, there are four chiral center, 1, 2, 3, 4. So stereochemistry or configuration of this chiral center is R, this S, and this is also R, and this is also R. So in the options there are so many in the four options like given like this 2R, 3S, 4R, 5R pentahydroxyhexanal. So this is a hexanal with 5 hydroxyl group. So that's why pentahydroxyhexanal. So in the four options the last part was given as pentahydroxyhexanal, but in this bracket the stereochemistry was different. So carbon 2 stereochemistry R, carbon 3 S, carbon 4 also R, carbon 5 also R. So 2R, 3S, 4R, 5R pentahydroxyhexanal. So this is the IUPAC name of the compound. So I think in this time more than 15 around 20 questions from organic chemistry they asked from organic chemistry around 20 questions, and more than 20 questions from physical chemistry, around 25 questions. So in this time less compound very less compounds from inorganic chemistry they asked. So I think 5 to 6 questions from inorganic chemistry and some questions from analytical chemistry, means that DTA, differential thermal analysis, and some questions asked from analytical chemistry, and also from nuclear chemistry very simplest and easiest questions they asked around 10 to 12 questions from nuclear chemistry. All the questions are regarding to the alpha and beta emissions, alpha and beta particle emissions. So question number 28, that is the IUPAC name. 29, so this naphthalene molecule, if we treat it with lithium or sodium liquid ammonia phase of ethanol, then there are four options. Out of them one is so the correct options is this, means when we treated naphthalene with liquid lithium liquid ammonia or sodium liquid ammonia, we can use sodium in place of lithium, then the Barch reduction will happen. So we will get this type of compound. And if we treat it with platinum hydrogen under pressure and high temperature, then the whole ring will hydrogenate. So we will get decalin molecule. If there is no pressure and temperature is moderate, then partial hydrogenation will occur. Only one ring, partial hydrogenation will occur. Only one ring will be hydrogenate. But since here high pressure and high temperature, so the whole ring become hydrogenate and we will get decalin. So if we use platinum hydrogen, then we will get cis decalin. In place of platinum, if we use nickel hydrogen under pressure and temperature, we will get trans decalin. So So these are the some reference from Nan Zeifel book. So see the Barc reduction of this naphthalene moieties. Yeah, the electron deficient ring is reduced. Obviously, reduce mean electron acceptance. So the electron deficient ring accept electron. So the electron rich ring cannot accept electron. So if there is two ring, on ring attached with substituent electron withdrawing substituent means that ring is electron deficient, and that ring under accepting electron become reduced. So in this ring is electron rich, mean two electron donating methyl group is there. That's why this ring will reduce. So in this case also, OH is the electron donating group plus R effect dominate, then minus I effect. So overall this OH group donate electron in that ring. That's why this ring will reduce. So in the questions, normal naphthalene molecule was given. There was no substituent. That's why for Barc reduction we will get this molecule. From platinum hydrogen we will get cis-decalin. I think there was no stereochemistry mentioned in the questions, but if they asked in next exam or upcoming exam, platinum hydrogen, cis-decalin, nickel hydrogen, trans-decalin. Let's move to the next questions. So this question is from physical chemistry, Fugacity. So the questions is like there is four options. Fugacity, in which case fugacity means F greater than P, pressure of ideal conditions. So this P is the pressure of ideal gases, and this F is fugacity, calls as effective pressure. So in real gas we consider the fugacity term. So there are four options. Out of four options we have to find the correct statement, from where the options was like the options were like F greater than P or F less than P in high pressure region or low pressure region. So the statement were like that. So yeah, we know that F equal to phi into P. So this is F fugacity, phi fugacity coefficients, P pressure. So this is the definitions. We can define the fugacity coefficient as ln phi integration 0 p z minus 1. So there is compressibility factor. So if we see this graph, then this straight line is for ideal case, z equal to 1 for ideal gas behavior. If we see low pressure region, means see this is low pressure region, this is high pressure region. So low pressure region, z is less than 1. So if z is less than 1 means this ln phi, so this integration become negative. Z less than 1 means this term become negative, so this whole integration become negative. If z is less than 1, then also from this equation we can say phi less than 1. So if this whole integration become negative, ln phi become negative, then also we can say phi become less than 1. If phi is less than 1, then this ln phi become negative, and if phi is less than 1, then from these equations phi equal to f equal to phi p, we can say f less than p. So low pressure region, in the low pressure region f less than p, fugacity less than the ideal pressure, so pressure of ideal gas. So if z greater than 1 means, see in high pressure region, this is the pressure axis. So in high pressure region, see high pressure region z is greater than 1. So if z is greater than 1, then this integration become positive, so ln phi is positive. So ln phi positive means phi greater than 1. So phi greater than 1 means from this equation we can say that f greater than p. phi greater than 1 means we can say F greater than P. So at high pressure region, F greater than P. So in the questions, four options four options were there. Two options is like that, in high pressure region F greater than P, in high pressure region F less than P, and in low pressure regions. So options are like that, but the correct option is, we already saw that in a low pressure region F less than P, in high pressure region F greater than P. In low pressure region, C, in low pressure region, in this case Z less than 1. Z less than 1 means this integration become negative. So ln phi become negative. Ln phi negative means phi less than 1. So from these equations, phi equal F equal to phi P. If phi less than 1, so you can say F greater F less than P means pressure greater than Fugacity. So in case of high pressure region, so this is the high pressure region. High pressure region means if we move forward to the pressure axis, so high pressure region, the Z is greater than 1. So when Z is greater than 1, the ln phi become positive. Ln phi means this integration become positive. If this integration become positive means ln phi positive. Ln phi positive means phi greater than 1. If phi greater than 1, from these equations we can say from these equations that F greater than P. So in high pressure region F greater than P. So this is the correct options. In high pressure region F greater than P. Also we can say in low pressure regions F less than P. So this is also correct options, but this option was not there, I think. So at high pressure region F greater than P. So this is from Fugacity. So ionic equilibrium. Let's move to the next question. So yeah, from Carnot engine, I think 2 or 3 questions. That question we already discussed, the how to increase the efficiency of Carnot engines. But I think more on questions, more 2 questions from Carnot engines they asked this time. So one is a simple questions that heat input was given. So I forgot the exact value, but the value is like this, but the value may be changed. So 8.47 or something, but positive value was given. So what is the work done if temperature is changed from 0 degree centigrade to 100 degree centigrade? So you all know the efficiency of Carnot engine, 1 minus T prime by T. T prime is temperature of HTR, T is temperature of HTR, means high temperature reservoir. T prime is temperature of low temperature reservoir. Also we know that neta, that's efficiency of Carnot engine, we can write work done by heat input. So from equations on, we will get the efficiency equal to, so 0 degree centigrade mean uh, so 0 degree centigrade means, so 273. So sorry for mistake. So here 2, this is not 3, this is 276. So 273 Kelvin. So this will also become 2, not 1. So 2, so also become, this is also become 2. So if we multiply with this 2, then it will become, so 1.79 into 2 means around 1.7 means around 3.4 or 3.5. So if we multiply this into 2, then it's become around, so 3.5 kilojoule. So sorry for this miscalculations. So this is also from Carnot engine. So first we calculate the efficiency from the temperature term, then we put the value work done. So work done is Wt, and heat input is was given as 8.47, or like some value was given, so around 8, or I forgot the exact value, but like 8 point something or some value was given. So from equation 2, so need the efficiency from equation 1, we put 200 by 473. So we just put the value in efficiency term eta. Now work done, we have to find the work done. So this kilojoule heat input was given, so we multiply into 10 to the power 3 means joule. So the work done is 3.5 kilojoule. So this is one questions from Carnot engine. Another questions asked regarding the how to increase the efficiency of Carnot engine. I think on more questions they asked from Carnot engine, but I forgot that question. So let's move to the next questions. So this questions from actually from quantum, you can say from quantum chemistry, just normalization of functions. So this that the function was given, so n is n as normalization constant, we have to find the value of n. So if phi is the normalized wave functions, then phi is equal to n psi. So from these calculations, this is the calculations, and we know that minus infinity to plus infinity, this phi star phi should be 1. This is the condition of normalization. So from these equations we will find, so see here, minus infinity to plus infinity, e to the power minus 2 alpha x square. So this e to the power minus 2 alpha x square is a even term. So since this is a even term, we can write this term, we can write this minus infinity to plus infinity, this whole integration in as 2 into 0 to infinity 0 to infinity dx. So here dx should be there. Dx should be there. So this is the properties of some integrations. So minus infinity to plus infinity, since this term is a even term, we can write 2 into 0 to infinity. So from this calculation we will find n equal to root over 2 alpha by pi whole to the power half. So just we have to calculate the normalization constant. So simplest and easiest question from quantum chemistry, or you can say that normally simple harmonic oscillator model, this type of question normally asked. And in the next question, I think same function was given, just we have to find find the average value of x. So we all know that average value of x, we can write that psi star x psi dx. So psi star x psi dx, so we can write x into psi star psi x. So psi star is e to the power alpha x square, so psi star psi x become e to the power minus 2 alpha x square. So in this case, see, minus infinity to plus infinity, x e to the power minus 2 alpha x square. So this whole term is a odd term. So since it's a odd term or odd functions, so the whole integration value will be 0. In case of even term, we can write this whole term as 2 into, change the limit of integration 0 to infinity like that. But when it's become odd term, the whole value of integration become 0. So the average value, the function was given, the average value will be 0. So the correct option was 0 for this average value. And for this integration, for this normalization constant, there was a term like that. So so maybe in this case alpha a may be there, in case of x r may be there. So but the function is like that, and the calculation is similar. Any function was given, so this function was given, this is normalization constant. If we find the normalized wave function, then we have to multiply the function with normalization constant. So the condition of normalization constant is the normalized functions psi star psi d, so dx, or you can say d tau, means the whole regions you can equal to 1. This is the condition of normalization. So from this we can evaluate the normalization constant value in any wave function is given. If there is any wave function given, so you can find out the value of normalization constant in this way. So 34. So on questions from, there are so many questions, and easiest questions from nuclear chemistry means radioactivity, just all considering the alpha and beta particle emissions. So from on questions, so one question is there, how to slow down a fast neutron. So how to slow down a fast neutron? There are 4 options: by passing through heavy water, by passing through 4 option was there. So the correct option is by passing through heavy water we can slow down the speed of fast neutron. So we can slow down the speed of fast neutron by passing through heavy water, means by passing through D2O. So, and more than 10 to 12 questions from radioactivity just related alpha beta particle, on elements emits alpha and beta particle, so what is the product? So just like that all the questions. So and next, so 2 questions from solutions regarding depression of freezing point. So 2 questions, same value were there, just in different concepts. So first case, on molar NaCl solutions assuming complete dissociations, Kf was given 1.86, what is the freezing point? So in this case, since we have to assume complete dissociations, so we have to consider the I factor, means Van 't Hoff I factor. So this is depression of freezing point I Kf, this is molality and freezing point depression constant. So if we consider any electrolyte, if we consider the dissociation of any electrolyte, then we have to if the degree of dissociation of alpha is alpha, then we can establish these equations. Alpha equal to I minus 1 x plus y plus 1. X is the number of cation or anion after dissociation. So number of cationic species or anionic species after dissociation of the electrolyte or the solute, not electrolyte, you can say here solute. So after dissociations, number of cation is and number of anion. This is the number of cation and number of anion after dissociations. So I is Van 't Hoff I factor. This is for dissociations, and for associations, if one solute associates into n mar, then we can find we can write these equations. Alpha equal to I minus 1 by n minus 1. N is n mar. If one solute associates into n mar, so dimar means n equal to 2, trimar means n equal to 3, tetramar means n equal to 4. So in these questions we have to consider the dissociations. So if alpha equal to 0 means degree of dissociation equal to 0, means there is no ionization. So we can write I equal to only 1. This becomes 0, so I equal to only 1. So if alpha equal to 1 means complete ionization. So alpha equal to 1 means complete ionization. So I become x plus y. If alpha equal to 1, then I become x plus y. So in the given questions, 1 molar NaCl assuming complete ionization. So in this case, I is equal to x plus y. So x is the x or y are the number of ionic species after dissociation. So NaCl, how many ionic species will form after dissociation? Na plus plus Cl minus, so 2. So in that case, del Tf, so this equation, now consider this equation, del Tf I into Kf into m. So for complete dissociations, we find that I equal to x plus y, means the number of ionic species after dissociation. So now we put x plus y in place of I, kf into m. So x plus y means number of cation is 1, number of anion is 1. So 1 plus 1 into 1.86 into 1 molar. So 3.72 is the depression depression of freezing point. Now del Tf is equal to, we know, T0 minus Tf. So T0 is the freezing point of solute and Tf is the freezing point of solutions. So T0 is the freezing point of pure solvent and Tf is the freezing point of solutions. So we have to find Tf, means freezing point of solutions. So now we have to find Tf, T0 minus del Tf. So T0 means freezing point of pure solvent is, that is 0 degree centigrade, means 273 Kelvin. So 273 Kelvin minus 3.72, 269.28 Kelvin. So the freezing point, of that solution is 269.28 Kelvin. So del Tf is T0 minus Tf. T0 is the freezing point of pure solvent. Tf is the freezing point of solutions. So this x plus y term came here because we have to consider the complete ionization of the solute here, NaCl. In the another questions, same value was given, Kf is equal to 1.86, 1 molar solution of a substance, but in this case there is no mention of dissociation or association. So we have to, in that question also you have to find the freezing points. So in this case del Tf equal to Kf into m. In this case I will be not there. When there is association or dissociations, I term, this is Van Hoff I factor, will be there. But in this case, since there is no mention of association or dissociation, so del Tf equal to Kf into m. I, in this case, I term is not there. So we just have to put del Tf equal to 1.86 into 1. So we have to find the freezing point of solutions. So we know that T0 minus Tf equal to del Tf. So Tf is equal to T0 minus del Tf. So T0 means freezing point of pure solvent, means that is 0 Kelvin, 273, 0 degree centigrade, 273 Kelvin minus 1.86. So it's become 271. So in that case we consider the complete dissociations, that's why I term came. In this case I equal to 2, means there is 2 ionic species after dissociations of the solute, that's why I term become 2. In this case no I term is there, so that's why only del Tf is equal to Kf into m. In that case del Tf equal to I into Kf into m. So 2 questions from that solutions regarding depression of freezing point. Same questions on considering association or dissociation of solute, on without association or dissociation of solute. So next, move to the next questions. So this question is from phase equilibrium. So I think these questions previously asked in NET or GATE. I forgot the year, but yeah, same questions was previously asked in NET, I think. So this graph was given, and in three straight line A, B, AC, and OA, corresponding slope was given, and the for particular AC, this AC means that liquid and vapor equilibrium. There is particular change in del H, means change in heat. So change in enthalpy was given like 1000 joule. I forgot the exact value, but something was given like that, joule, and particular at a particular temperature, that is 100 Kelvin, I think. So slope of AC, this slope of this straight line was given as 10 pi by 3. Now change in volume we have to find, dV. So from Clapeyron equations, we know the Clapeyron equation is dP dt equal to ds dV. So this plot is P versus T plot. So the is in this plot, if there is any straight line, so the slope will be dp dt. So dp dt equal to ds dv. So we can write the ds as del a is by t into dv. So ds equal to del a is by t into dv term is here dv. So we can write ds on only del a is by t. Now from these equations we can write dv equal to del a is by t into 1 by slope. So this is a p by t plot. So any straight line if we draw here, the slope is dp by dt. So the slope of AC is given as tan pi by 3. So if we put the slope here tan pi by 3, so it's become cot pi by 3. 1 upon tan by 3 means cot pi by 3, and this value becomes some, I think 10, but I forgot the exact value. Maybe the delays value might be changed and t also, but this is the fundamental theory behind this behind solving this problem from this phase equilibrium graph. So pt plot was there, straight line, slope is dp by dt. So a particular line slope was given, and for this slope means liquid vapor equilibrium, this line uh, this line this line is the liquid vapor equilibrium. So this line shows the liquid vapor equilibrium. So from Clapeyron equation we know that dp dt equal to del s del v. Just we have to we put del s by t in place of del s. From these equations we can easily find out the dv means change in volume. So it's become 10 cot pi by 3. So might be in this value 10 may be changed. So 1 upon 10 pi by 3 means cot pi by 3. So the correct option is cot pi by 3, and the value here 10, or maybe that value might have changed, but I forgot the exact value. So this 10 value will depend only this del a and t. If del a is changed and t change, then this 10 value, this term will also change. So next move to the next question. So this is the question. So in this four complex is there. So in which complex bond present? So in these questions on doubt is there means we know that Mn bond present is this MnC2, Al2CH3. There is no aluminum bond. Al2Cl6 also there is no aluminum bond. But V2CO12, if this is formed, then also there should be metal bond, Vb bond. But we know that this V2CO12 is not formed at all, because if it is formed, there is vanadium is small size and there will be 7 coordination number of vanadium. So that's why V2CO12 will not form at all. But for attaining that 18 electron rule, it will transform into a carbonylate anion VCO6 minus by accepting electron from metal. So instead of dimerizations, it will accept electron from metal and transform into carbonylate anion. So this type of anion is called as carbonylate. But in the questions, yeah, I am sure that V2CO12 is also there, but in the options, in the 4 options, so in the 4 options, one option is Mn2CO10. So there is no options who is containing this Mn2 and V2. But 4 options, 4 complex, different 4 complex was there. So in the question this complex was given. So we know practically this complex is not formed. So that's why if we consider that thing that this complex is actually not formed, then the correct option is only this Mn2CO10, and option A, or I think option C, this option was there. But in one options V2CO12 is also there. But so if it is formed, theoretically if it is formed, then Obviously there is VB bond, vanadium vanadium bond, but we all know that this complex is actually not formed. So I think we have to consider that thing, means this complex is not formed at all practically, so that's why it's an unstable complex. So and this Mn2CO10, this is a stable complex somewhat. So in this complex metal metal bond is present. So out of 4 options, the maximum possible correct answer is Mn2CO10. In the options, I am sure that V2CO10 also there, but I think that was not correct option, because we have to consider the uh, we have to consider the thing that this V2CO12 is not formed. Yes, they are given the complex, but we have to consider this phenomena, because V2CO12 is not a stable complex, it is completely unstable complex, it is not formed at all. So that's why according to me, from this for this question, the correct answer is Mn2CO10. So let's move to the next questions. So titanium 3 plus, ruthenium 3 plus, rhodium 3 plus, chromium 3 plus, this 4 transition metal ion are given. So from there the question was like that, out of 4, the statement was like that, out of 4, 3 are inert and 1 is labile. So the labile one is. So we all know that this 4D and 5D series metal always low spin. So ruthenium is iron series, means ruthenium 2 plus D6 low spin. Rhodium is cobalt in cobalt group, means cobalt, iridium, rhodium. So cobalt 3, rhodium 3 plus also D6 low spin. We know that the D6 low spin uh, ion is inert. Chromium 3 plus, we also know that D3 configuration is also inert. D-on, titanium 3 plus is D-on, so we know that D-on configuration is a labile. So from CFT, we can find this, we can summarize this table like this like a table. So D0, D1 and D2 metal ion are labile, always labile. D3 always inert. D4, if high spin then it's labile, if low spin then it's inert. So crystal field splitting energy become, this case become more, this case become less, that's why it's more inert. So D4 high spin labile, low spin inert. D5 high spin labile, low spin inert. D6 high spin labile, low spin inert. And D7, D8, D9, D10 always labile. So this is a very important table. So from this table you can find the lability of some ions uh, and inert nets of some ions. So in the question, titanium 3 plus, ruthenium 2 plus, rhodium 3 plus and chromium 3 plus are given, and the statement was like that, out of 4 cation, out of 4 ions, 3 are inert and one is labile. So the labile one is, titanium 3 plus. So D1, D0, D2 always labile, D3 inert, D4, D5, D6 in this 3 D configuration, 5, 4, 5, 6. High spins are labile and low spin are inert, and D7, D8, D9, D10 always labile. Next, move to the next and last question of this part 3, uh, third video of memory based question answer series. So this question is from group theory. So character table of 3V, the C3V point group was given, and we have to find the Raman active mode. So also this total irreducible representation was given like that, 1202. Yeah, 1202 I think, but I forgot this term, but 80% sure that this term was 1202. So from there we have to find the Raman active mode. So if we try to find the total vibrational modes, then from this we can find in this way. 1 by 6 means order, so 12 into 1 into 1, in this case 0, so into 1 means 0. So in the third case 12 into 2 into 1, and plus this term becomes 0, and also second term becomes 0. You all know the how to find this number of reducible irreducible representations. So we will find 3a1 plus a2 plus 4e, that these are the total vibrational modes. So out of them Raman active modes. So from this table we can easily, without any calculation, from this table we can easily find out the Raman active mode and IR active mode. If the table yeah, first we have to find the total vibrational mode. From this vibrational mode, we have to find the IR active mode and Raman active mode. Raman active mode and IR active mode belong to this total vibrational mode. So Raman active mode and IR active mode should belong to this total vibrational mode. If we find out the total vibrational modes, then from this table, see, if there is quadratic term, means the last column, if there is quadratic term corresponding the uh, irreducible representations, means if there is any quadratic term, so that term become Raman active. See, A1 corresponding term there is quadratic term, E corresponding there is quadratic term, means xy or square term, so that term become Raman active. If there is no term in that column, so that's means that molecule symbol, or you can say irreducible representations become Raman inactive. If there is linear term, means xyz or rx ry, then that corresponding molecule symbols or irreducible representation are IR active. So see, z is there, a1 also IR active, rz linear term, a2 rz term is there, IR active, e this term is there, xy, so IR active. So quadratic term corresponding Raman active, linear term or that's xy term corresponding IR activity. So since a1 a2 e, these three irreducible representations are IR active, but only a1 and e is Raman active, because in this column there is no term, square term. So see, first I told you that this is total vibrational mode. From this vibrational mode we have to find the IR active mode and Raman active mode, and those Raman active modes and IR active modes should belong to this total vibrational mode. But all these total vibrational mode are not Raman active, are not IR active, but IR active and Raman active modes are, that IR active modes and Raman active modes should belong to this total vibrational modes, but all these total vibrational modes may not be IR active or Raman active. So from 3A1 only 2A1, and from 4E only 1E is Raman active. So see here, A1 and E in the options, only one option is there, that is 2A1 plus E. So we can see from table, quadratic term is there corresponding A term, A1 term, and quadratic term was there corresponding E term. So in the options where A1 plus E is there, that representation is Raman active. So this is regarding so this is from group theory. So another question asked from group theory, that is from group, that is a point group. So I think we already discussed 40 questions, so 60 questions still left. So yeah, we will try, because we have to remember the questions, and that's why it will take time. So but we already discussed 40 questions, and yeah, I am, so Yeah, I am telling you that all the questions are straightforward this time. Lots of questions from organic chemistry, more than 15, means around 20 questions from organic chemistry, around 22 to 23 questions from physical chemistry, that chemical kinetics, electrochemistry, thermodynamics, and 15 to 20 question from nuclear chemistry. That's are very easy. But I forgot the exact elements, uranium, whether it is lead or krypton, strontium, but all the questions are based on the alpha and beta particle. So if you see the video, I uploaded the video regarding the radioactivity. We discussed 9 questions or 8 questions. So all the questions regarding same as we discussed in that video, same questions only regarding alpha and beta particle. No conceptual questions from radioactivity. And that yeah, some questions they asked from analytical chemistry, that is DTA, differential thermal analysis, and thermodynamic analysis, like that. But maximum means around maximum questions from physical chemistry, and second came organic chemistry, very low, very less questions from inorganic chemistry. And so around 25 questions from physical chemistry, 20 around 15 to 17 questions from organic chemistry, 15 questions from more than 15 questions from nuclear chemistry, and the other things analytical or from mix up of that analysis or other things. But all the questions are very straightforward. So focus on organic questions and physical questions. So we don't know in the next phase, means 6th April, what will be the question types. But since they asked very easy question in this first phase, so I hope in second phase also they will maintain the quality. Otherwise, otherwise there will be so difficult to interpret the result of the exam. So thank you guys, thank you for watching, and thank you for your support. So yeah, we will upload more videos regarding this memory based question answer series. So till now, so that's all, and thank you again. So stay safe, stay healthy.